Hello everyone, welcome to Grade Up. My name is Hemant Parihar and today we will be learning about IP4 header and IPv6 header. So we have seen in our previous lecture we have seen subnetting, supernettings, all these kind of things. I hope you remember all these, and now today we see IPv4 header. So let's start. So in IPv4 header, this is the format. This is the format. If you see, this is the format, and I will explain you every field in this IPv4 header, and every field is important because they asked lot of questions from IPv4 header. So this is version. So version will told you about whether it is IPv4 or IPv6. So for this we have 4 bit, and this is header length, and for header length we have also 4 bit. Okay, and type of services. For type of services we have 8 bit. In type of services, what we actually told is that if you wanted to send your packet from less traffic, then you can give priority from this, and you wanted to make sure that it will deliver fast, then you can do some kind of priority here. So these 8 bit will determine the priority of the packet. Okay, and they are a type of service. This is total length. So total length determine the header length. Total length will say about header length plus payload length. And what is payload? Payload is our data. So this is payload plus header length. Both length is coming inside the total length. Okay, and it is 16 bit field, and this is identifier. So actually what happen when a process send data to another process, so it will sending in the packet. So this will be packet number 1, packet number 2, packet number 3. It will send like this, so that at the receiver it will be easy to collect them and make them in sequence. So that is why we will be having an identifier, and it is also 16 bit. These are the flags. So I will tell about these flag more. So okay, this is 3 bit flag. I will tell you about this. And this is fragment offset. So I will talk about fragmentation right now after this slide, 1-2 slide. So I will tell you about the fragment offset in more detail. Okay, and this is 11 bit. This is 13 bit. Okay, this is 13 because 3 16, so it will be 13 bit. And this is time to live. So time to live tells that at much how hope it can travel. So I will talk about it, why it is there. It is also 8 bit, and this is the protocol. And what this field consists, it consists the protocol of the upper layer. For example, if you have used the TCP protocol or UDP protocol, so it will be there. Okay, so that is why it is used. And header checksum, it is 16 bit. So we already know what is checksum. What we are going to do, we are going to divide the bits and then we convert them into their decimal representation, then we sum it, and then negative of it will be present in this field. So that is what is header checksum. And we will be having source address. Source address is 32 bit. Okay, and destination address is 32 bit in IPv4. In IPv6 they are different. And so this is always present. These fields are always there in the IPv4 header. If you calculate them, this is 4 byte, this is 4 byte, this is 4 byte, this is 4 byte, and this is also 4 byte. So 5 times 4 byte, that means 20 byte header is always present, IP header. And these are the optional. So in optional field, what we are going to place, I will tell you. And this is 40 byte. This is 40 byte. Okay, and this whole padding plus option are 40 byte. Okay, both are 40 bytes. So that is actually why padding. Suppose if you have sent 13 bit, then what you will do, you will add 3 more bit to make it 2 byte. So that is why we are adding here padding. So I will talk more about in all of these field in details. Okay, so and try to remember this. Okay, if you write 1-2 times in your notebook this 4 bit, 8 bit, you will remember it. Okay, and more important, why it is there, also understand them, otherwise you will forget it. Suppose I will tell you why identifier is there, and I told you that why it is there, fragment offset why it is there, all these things you should know why they are needed. Okay, Now I told you that minimum size of header is 20 byte. Minimum size will be 20 byte. Options may or may not be present. And when all the options are present, means we are using the option field completely, means 40 byte we are using, then the size of IP header will become 60 byte. So it is varying from 20 byte to 60 byte. But if you see that, I told you how many bit are used for header length, 4 bit. So header length we have used 4 bit. With 4 bit, the maximum number you can get is 15. How? 1, 2, 3, 4. That is 15 in decimal. So you get the maximum 15, but header length can be 60 or 20, at least 20 and maximum 60. So how with 4 bit we are going to represent it? So we are going to do some scaling. What we are going to do? We are going to take the maximum 60 and divide it by 15 and take the seal, that is 4. So we have done the scaling. This is the scaling factor. So what I'm going to place in my header length, for example, I have write this. Header length is 20 byte. I want to represent 20 byte. So how I am going to do? I will write 4 this as a header length field. This will be written in header length field, and when the router is going to take this, it is going to understand, or destination going to take this, it is going to understand that we have to multiply it with 4. It should be 5 because header length is 20. So 5 into 4 is 20. So like this it is understand. Suppose you wanted to send 60 byte. So header length field will be look like 1, 2, 3, 4. It is in decimal 15, and we are going to multiply with scaling factor 4 to get 60. So that is the importance of the scaling factor. Okay, remember this. This is really important. Sometimes we do mistake by seeing how for this is the header length, so whatever be placed here, this will be the header size, but it is not like that. Okay, and how we are going to represent the version of the IP header? So for we are going to represent this IPv4 and IPv6 like this. So it's easy. Okay. So I told you that fragmentation. What is fragmentation? So what happened that this network here at the router, we will be having physical layer, data link layer, common network layer, and physical layer and data link layer. So these LAN property here I am using and the here I am using may be different. They may be different, and the router knows that both of them. Router knows what is the maximum data they can carry. So these are different, but router will have common only one network layer, but two physical layer and data link layer. Okay. So here if you see that here we have MTU is equal to 520 byte, but here we have 200 byte. So what is MTU? So it is the maximum amount of data that a frame in data link layer carry. So here data link layer is important. In data link layer, what we are going to do? We have a payload, we have an IP header, we have included both of them, then it is going to data link layer. So that is what it is. We have included the IPv4 header also. Okay, IPv4 header also it is including self. So here we have a packet. Suppose here one packet we need to send, and whose size is 5, whose MTU is 520 byte. How it is going to send? Because the maximum transable unit here is 200 byte. So how we are going to do it? We are going to fragment the packet, and how we are going to do it I will tell you. So this is our packet. I told you it will include, we are assuming that we are including 20 byte IP header, only 20 byte. We can go to 60 byte, but here we are assuming we are only adding 20 byte IP header, that is the minimum. Okay. So 500 is our data. We need to send actually 500 byte and 20 byte is for header. This is not what we, header is not our main purpose to send it. Our main purpose is to send the data. Header is included so that it will reach properly to the destination. So the main purpose is we need to send the 500 data. Here MTU is 200 byte, among which 20 byte will be for header, and the maximum I can send is 180 byte. The maximum I can send it 180 byte. So if I remove 180 from 500, how can I 180 then 180, this will be 360, and this 140. So I am able to divide my 500 byte like this, and I am sending like this. Okay, so here 180 byte is sent, 180 byte is sent, 140 byte is sent. So like this I have to send, but there is a problem. Total length field is 16 bit, and if you see the fragment offset field is 13 bit. I show you one more time. See here, this is 13 bit and this is 16 bit. Okay, so this is 13 bit and this is 16 bit. So, and fragment offset, what it will tell the number of byte. Suppose you have a packet and you have fragmented that packet, so the fragment offset will carry the number of byte that is already sent from that packet. Okay, so I will tell you more about it. So if you see here, this is only 13 bit and this is 16 bit. But if our size is completely about packet size is almost 2 power 16, then these 13 bit are not able to represent that. So we are going to use again scaling. So how we are going to use scaling? 2 to the power 16 upon 2 to the power 13, that is 8. So we are going to use the scaling factor as 8. So whatever we are going here, it should be multiple of 8. It should be multiple of 8, because we writing the fragment offset here. Okay, we are writing the fragment offset in field. So whatever data we are sending, it should be in multiple of 8. So 180 is not divisible by 8. Try to divide it, it is not divisible by 8. What is the less than 180 that is divisible by 8? 176. So I am going to send 176 in first packet. Similarly in second packet 176, and how many remaining? 148, which is divisible by 8. So that is fine. So I am going to use this. Now what I am going to place in my fragment offset field? So for this is the first packet, this is second, and this is third. So for the first packet, how many byte are ahead? There is no byte ahead, because this is the first fragment. This is the first fragment and there is no byte ahead. So I am writing here 0. Now for the second packet, how many byte are ahead? 176 bytes are ahead. For this one packet, 176 byte are ahead. But I told you that in fragment offset, what we are going to write? We are going to use the scaling factor 8. So divide this by 8 and what we got? 22. So 22 will be the fragment offset. And how destination is going to take it? Destination, see that it is 22, it will multiply by 8, and understood that 176 byte are in the first packet. So that is how it is going to work. Similarly for 3, 176 plus 176, totally how many? If you count 176 plus 176, these many bytes are ahead from third packet. Now but you need to write into by divisible by 8. So divide by 8 and you will get 44. So this is the fragment offset for third packet. Okay, and I told you about the flag. There are flag, so which is 3 bit. So first one is 0, it is always 0. Okay, second one is do not fragment, DM, and the third one is more fragment. So these are the 3 bit: 0, do not fragment, and more fragment. So more fragment will tell you that there are more fragment coming from this packet. So for this packet you will write 1 here. 1 will show that there are more fragment are coming from this packet. Okay, similarly here 1 will represent there more fragment are coming, but here it is 0 because no more fragment are coming. So that is how it is working. And do not fragment means if you make it as 1, it means you cannot fragment the packet. So when this router see that this packet has this is 1, then it will discard the packet. This packet will be discarded and an ICMP packet will be sent, that we will be learning about it, and it will going to tell the source that why it is discarded and what should it do. What it will do, the source is going to do the fragmentation now. Now source will send it accordingly to the MTU of this network. So this is what it is going to do. Okay, I hope you understand this fragmentation. It is really important. Lot of question has been asked from GATE from this topic, so understand it completely. Now the other field are TTL, so that was time to live. So what's happened that, suppose this is the router and it is connecting to it. Okay, it is connecting to it. Now when this router got a packet, suppose it router get a packet, and according to him it is not, he don't know the IP address of it. The IP address does not belong to its coverage, whatever it is covering. So it is going to send it to default gateway. Suppose its default gateway is this. Now same is happening for this packet. He does not know to which it is sent, so it is going to send it to default gateway. Now when it come to this router, it is also don't know, so it is going to send to default gateway. Now this packet going to loop always, and it will cause more traffic. So we included TTL. At every hop we decrease it by 1, and when it becomes 0, packet will be dead. For example, if I have written 1000000, so it means that it can pass through 4 hop, because value is 4. It will go to one router, it will decrement it by 1, then it will go to the next router, it will also decrement by 1, it is go to that router, it is decrement 1, it is go to that router, it is decrement 1, and it will become 0, and so it is now going to delete that packet. So that is the purpose of time to live. Now we will see protocols. So I already told you that in protocol field we will be having the protocol number of upper layer. For example, TCP protocol we use, UDP use, ICMP use, or whatever we have used, that will be written here. And in option field, which is 40 byte, what we are going to do, there are two things. Record route. Suppose you wanted to record the route, then in that case you can write the IP address of that packet, that router from which it is going. So whatever the packet, and when destination get that packet, destination will know that which path it has followed. So that is the purpose of record routing. And there is source routing. In source routing, you wanted to send your packet to a specific path, then you are going to source routing. Okay, it is of two type, loose source routing and strict source routing. In loose source routing, it may, so for example, you are the source and you want, this is the router and this is router and this is router, okay, and this is the destination, and there are other router also, but you wanted to send your packet from this and this router. Okay, then what will you do? You will use if you want to send only this router and this router, then you are using the loose source routing, because the packet can follow this path also and this path also. But in strict routing, you mention all the router, this like that. So that is the difference between strict routing and source routing. Now we will see the IPv6 header. If in IPv4, this header, there is nothing like we have every packet is distinguished. Every packet means whenever router get packet, it will take it as individual packet and it can send it to any way. For a router, it is a complete distinguished packet, and there is nothing like that we have reserved the resources for a packet. But in connection layer, in IPv6, we will see what will happen. So in IPv6, we have version, that is 4-bit. We have traffic class, that is 8-bit. So traffic class is doing what? It is like the priority type of services field. So in IPv4 we have seen the type of services, it is same as like this. We have flow label. So flow label is 4812, it is 20-bit. So what do you mean by flow label field? Actually, suppose this is the router and this is the source and this is the destination. If a packet come to that router, now it will check the flow label. If it has the same flow that it has recorded, then it will understood that to which path it has to send. Suppose this has a flow level something 200, then this router for 200 have reserved some resources, it has reserved some bandwidth, and it will direct it to some specific path. It will reserve some bandwidth, buffer, and all these kind of thing is reserving for this flow level. Then it will direct it to that part. Okay, and that it will go like this. So in using flow level, we can reserve some resources, and when we are reserving some resources, it means that it is connection oriented. It is connection oriented. So IPv6 can be connection oriented. IPv6 can be connection oriented. When we use the flow label field, it will become connection oriented. If we are not using the flow label field, it will become connectionless, and every packet will be complete a new packet for a router. It will not distinguish it as a special packet. So okay, so when we use flow level, it will become connection oriented. When we are not using flow level, it is connectionless. So that is a great difference. This field make a great difference, because connectionless and you are getting higher priority for a packet and many more things. This is payload. Payload is 16-bit. Payload length means data byte. Okay, this is 16. This is 8-bit. Next header means it will have a code. For the next header, we are going to include it at here. Okay, I will tell you about this next header. This is hop limit. Hop limit is same as time to live. It is same as time to live. It is also 8-bit. We have source address. Source address is 128-bit, and this is 128-bit also. See, 128-bit is very much. Earlier we have 32-bit. 32-bit may be extinct. Now we are facing a problem that we are not having so many IP address with. That is why we have gone to IPv6, and IPv6 has 2 to power 228 IP. This is very huge number. And for I think about 50 years, we are not going to face a problem that we are getting less IP address. This is very huge number. If you try to calculate it, it is very huge. Okay, so this is the basic header. This is the base header. Okay, this is the base header in IPv6, and it is 40 byte. 40 byte. How 40 byte? 16 byte here, 16 byte here, but 32, and then 4 byte here, 4 byte here. So it is 40 byte. Now we are going to add some other header. Okay, accordingly. Okay, if we wanted to the fragmentation, if we want, these are header knows other information. For example, if we want to do the fragmentation, then this information will be there, and source routing kind of information will be there. Okay, so these kind of information will be present in this header, and they are known as extension header. Okay, and the code for these header will be written here. Okay, as we do not have here header length. Why we do not have header length here? Because it is fixed 40 byte. But these header, extension header, may have header length, so that we determine it. Okay, but this payload length will consist header length, these extension header length plus payload data. It will containing both. Okay, so these are the sum of the header extension. We have hop by hop option header. Okay, so in this we may tell that to which hop it should go. It value is 0. Okay, so this kind of field will be there. Routing header, fragmentation header, destination option header, and these are some for internet security. So these header may be present in the extension header, and their code will be written there, so that a router will understand that the next header will be this, and these header will have the length field, so that we know about their length. Okay, so now we will do one question that is asked in GATE 2013. So read it carefully. So in an IPv4 datagram, the M bit is 0. M bit, M is more fragment. Okay, so this bit is 0. So that means there is no more fragment coming. Okay, this is the last fragment. That is what you can understand from this. The value of header length is 10. Okay, the total value of total length is 400. Okay, the fragment offset value is 300. The position of the datagram, the sequence number of the first and the last byte of the payload respectively are. So what it is asking, what will be this sequence number of this fragment? Sequence number, it is asking the position, whether it is the last, middle, first, like that. Okay, we have given here middle, last, first, and I told you that as m bit is 0, we can understand it is last fragment. Now I see option A and option C seems to be the right answer, but to answer is which of these are, we need to see other things. So header length is 10. So header length is 10. We are using the scaling factor 4. Then total header will be 40 byte. Now total length in this packet will be 400 minus 40. So this will be the data that is present here. So it consists of 360 byte. Now question is asking what will be the sequence number of this byte and this byte. Okay, that is what the question is asking. The sequence number of this byte will be the number of byte we have already transmitted in earlier packet. Okay, so this will be, how can we know about the sequence number of this? Using fragment offset. Fragment offset has value 300 and the scaling factor is 8. So 2400 will be the sequence number of this byte. And what is the size, what will be the length? 360. So if you add 2400 plus not 359, because this is 1, this will be the last, you will get 9572. This will be this one. Okay, 2759. What is the right answer? Option C is the right answer. Okay, so that's all about today. We learned about IPv4 and IPv6 header. We learned about the fragmentation. So do practice in fragmentation. Okay, it is very important topic and keep practicing. Thank you.